bottom waters in the ocean also weakened, and there was less oxygen carried down into those bottom waters in the ocean. So, instead of cold, dense, oxygenated polar water sinking down to the bottom of the oceans, like happens today and probably like happened before the end of the Permian, instead, warm, salty, oxygen-poor tropical water started sinking to the bottom of the ocean basins. Well, there are some creatures that can live without oxygen, but most of the sea creatures living on the ocean floor need oxygen, and they started to suffocate. The oceans became starved for oxygen, and the extinction started to spread, starting in deep ocean basins and gradually filling the oceans until the suffocation extended right up onto the continental shelves, the shallow seas that surround us on the continents. Now, there were creatures who got along just fine without the oxygen, and some of them were sulfur bacteria. Sulfur bacteria, they do their energy manufacturing business not with sunlight, but with sulfur. And they release hydrogen sulfide as a waste product instead of oxygen. Now, hydrogen sulfide is not only a poisonous gas, but it also destroys ozone. And so in some scenarios, the hydrogen sulfide, the anoxic, the oxygen-starved oceans support sulfur bacteria. The sulfur bacteria make hydrogen sulfide. The hydrogen sulfide destroys the ozone layer, and all the creatures living on land are in trouble as well. Now, I'll tell you right now, this is kind of out on the limb. This is the extreme case. Sometimes the paleoclimatologists are working at one-upping each other. Well, if we drop the carbon dioxide level just a little bit more, we can get more sulfur bacteria, and then we can do this and this and this. So I'm giving you a worst-case scenario here. But when we look at the fossil record, we start to wonder if maybe we wouldn't be justified in thinking about worst-case scenarios, because we lost, conservatively, 85% of the species of marine organisms. Some estimates go as high as 95, and I've seen one that I really don't believe. I mean, it was on Wikipedia, but it said 98. But certainly 85 is a conservative estimate for the number of species in the oceans that became extinct during this event. Whether it was ultraviolet radiation flooding the land or something else, at least 70% of the animals living on land became extinct as well. The photosynthetic creatures, the plants, the phytoplankton, the marine plankton in the oceans were decimated, and we do find evidence of oxygen levels falling in the rock records. Fungi, though, did quite well. There were at least a lot of dead things around for them to decompose. So, it was the great dying, but the fungi, they got along great. And the age of mammals was postponed. The dominant animals at the end of the Permian period, 250 million years ago, the dominant land animals were mammal-like reptiles. Then this mass extinction happened, and so many of them were wiped out that they kind of missed their call. And so the next era is not the age of mammals after this, it's actually the age of reptiles, the age of dinosaurs. It was the dinosaurs that somehow managed to come out of this massive extinction in a little bit better shape and went on to rule the world for 160 million years before the mammals got their chance. Well, now, this idea of mass extinction by global warming, by carbon dioxide excess, is something that's, I won't say brand new. People have been talking about it now for 20 years, but it is gaining more and more favor. It doesn't explain all the mass extinctions in the Earth's history. Most, not all, but most paleontologists think that the dinosaurs died out at the end of the Cretaceous period probably because of a meteor impact. The meteor impact may not have been the only thing going on, but it certainly seems to have been the coup de grace, if nothing else. But there are 4 other major mass extinctions. And I've listed them off here: the Ordovician, Devonian, the Permian that we were just talking about, and another one at the end of the Triassic. And all of those do show some signs of being caused by runaway global warming. Well, now, after that mass dying, I said that, the mammals kind of missed their cue and the dinosaurs took over the world. Here at Grand Canyon, okay, who didn't notice that they drove 90 miles to come in? There at Grand Canyon, and here at Flagstaff for the most part, we don't have any rocks from the age of the dinosaurs. We do find them off to the northeast, off on the Navajo Nation, up to the north of us in southern Utah. And what we do find is that during that period of time, the age of the dinosaurs, the early age of the mammals, about another mile of sediment was deposited, turned into rock. But since it's already been eroded away, it's kind of hard to talk about specifics. Suffice to say, though, that climates did moderate. We returned back to cooler climates. New ocean basins opened up. The Atlantic Ocean opened up between North America and Europe, South America, and Africa. The Indian Ocean opened up. And then early in the age of the, or about midway through the age of the mammals, the temperatures cooled even further as the Himalayan mountain ranges began to rise. And temperatures continued their downward trend until finally about a little over 2.5 million years ago, we entered the ice ages, the Pleistocene. And here what I'm going to do is focus specifically on some of the things that have happened at the Grand Canyon during the Ice Age, during the Pleistocene. There were geological effects that we can see on the Colorado River and the carving of the Grand Canyon. There were biological effects that we can see on creatures that live at the canyon and creatures that no longer live at the Grand Canyon. One thing that we don't see at Grand Canyon during the Ice Age is very much ice. We didn't have glaciers. Our closest glaciers at Grand Canyon were actually the ones right here on the San Francisco peaks. So even though we didn't have glaciers at the Grand Canyon, though, the presence of those glaciers did affect what was happening in the canyon itself very fundamentally, because the Colorado River is fed by snow melt, ice melt, glacier melt from the Rocky Mountains. And so what we find is that as the glaciers were growing, as they were spreading in the Rockies, as those tongues of ice were grinding their way down the mountainsides, crunching up the rock on the sides of the peaks, all that crunched up rock was going someplace. It was coming here. It was being carried by the Colorado River through the Grand Canyon, but there was so much of it that the river couldn't carry all of it. And actually, thick layers of river gravels began building up on the floor of the canyon simply because the sediment supply was more than the river could carry away. The walls of the Grand Canyon, though, were a different story. The walls of the Grand Canyon, no glaciers there, but more rainfall. More rainfall means more plants. More plants means more roots. And so today, we're used to looking out there into the Grand Canyon and seeing all those beautifully colored rocks. It makes your little geological heart just kind of pit-pat. During the Ice Age, the Grand Canyon was a whole lot greener. All those sloping rock layers that we see exposed in the Grand Canyon today were probably covered with thick growth of vegetation on soils that had built up as a result of the wetter climate in the Grand Canyon during the Ice Ages. So the Colorado River was carrying more sediment and piling it up at the bottom of the canyon, but that sediment wasn't coming from the walls of the Grand Canyon itself, because there the sediment was actually starting to be stored in these soil layers along the canyon walls. Another evidence that we see of the Ice Ages at the Grand Canyon and that increased precipitation are thick deposits of travertine that formed in various places in the Grand Canyon as springs began to flow more strongly, carrying dissolved minerals from the canyon walls, from caves, from the spring lines, and depositing them on the surface as those spring waters emerge. So if you've ever been to or wished you'd been to places like Elves Chasm with the thick travertine walls there, or places like Havasu with the big travertine dams with the waterfalls flowing over them, a lot of that travertine is the result of that increased precipitation during the Ice Ages. The plants that were living at the